Today we're going to talk about matter in terms of elements and atoms. Your learning objective is very simple. You need to be able to define an element and an atom, be able to describe the three subatomic particles that make up an atom, be able to determine all three subatomic particles using information from the periodic table, be able to draw a Bohr diagram of an atom, and define a valence electron. So what is matter and how does it relate to atoms? Well, matter we know is all the stuff around you, which is made up of tiny particles that we call atoms. Atoms we know are the smallest particle that make up matter. They're composed of three subatomic particles: protons, which are positively charged particles, neutrons, which are neutral particles, and electrons, which are negatively charged particles that move around the nucleus. The nucleus is the center of an atom that contains both protons and neutrons. Here's a picture of that where you can see that in the middle you see the nucleus, where you see the protons, which are in red. In purple you see neutrons. On the outside you see a shell, which is an area where the electron lives. So what are elements? Elements are substances that contain only one type of atom. It cannot be broken down into any other substances by any ordinary chemical means. For example, pure aluminum contains only pure aluminum atoms. Elemental copper contains only copper atoms, etc. Another example is that graphite and diamonds are made up of elemental carbon. They're both made up of carbon, which is interesting because they look so different. Some info about elements. We know that there's 160 known elements today. 93 occur naturally on Earth. There's 23 that are not found on Earth, which are derived artificially. Of those derived artificially, those elements we know are radioactive with very short half-lives. Many elements come from Greek or Latin roots, and many that have been discovered are named after countries and sometimes famous scientists. Life, for example, only requires 25 of the chemical elements out of the 116. So let's take a look at your body. The chemical composition of your body contains oxygen, carbon, hydrogen, nitrogen, and other trace elements. 96% are made up of those four elements: oxygen, carbon, hydrogen, and nitrogen. So we know that elements are a group of the same atoms. Well, there's this table out there called the periodic table, which arranges the elements, which is the arrangement of elements that are found both on Earth and in space. So all the known elements that we know about are placed on this table. Important information found on the periodic table are two numbers: the mass number, which equates to the number of protons and neutrons in an atom, and the atomic number, which is the number of protons in an atom. Here's a picture of the periodic table. This number above represents what we call the atomic number. Again, this tells us the number of protons. Down below, you see this number, which is called the mass number. It tells us the number of protons plus neutrons. As you can see here, some of these numbers, or most of these bottom mass numbers, are in decimal form. Now you might be wondering if there are fractions of protons and neutrons. Well, that's not the case. The reason why you have decimals is because these are average numbers found on Earth. And we'll get to that later. As you can see here, the periodic table is organized in a way where it organizes from least to greatest atomic number. So it goes in order. On the periodic table, sometimes you see elements written like this, where the top number, the big number, is always going to be your mass number, and that's usually a whole number, and the bottom number is the atomic number. And in the middle, you see a chemical symbol. K stands for potassium. So how to find the number of protons? Well, it's simple. All you do is look at the atomic number. In this case, this is silver, and silver has the atomic number of 47, which means that it has 47 protons. Also, if we're dealing with a neutral atom, it also equals the number of electrons. Okay, so in this case, silver has 47 electrons. Neutrons are a little bit more tricky. What you do is you take the mass number. In this case, we're going to round, so this is 107.8. We're going to round up to 108, and we're going to subtract it from the atomic number, which is 47. And we'll get the number of neutrons. Electrons are easy. They will equal the number of protons if we're dealing, again, with a neutral atom. Here's a sample. We have phosphorus. We have phosphorus 31. So, how many protons are there in the nucleus of phosphorus? Well, we know that phosphorus has an atomic number of 15. So therefore, the number of protons equals 15. How many electrons? Well, if it's neutral, it's going to have the same number. So therefore, it's going to be 15. And finally, how many neutrons? Well, this one we have to do a little math where we take the atomic mass, 31, minus the atomic number, which equals 15. And we should get 16 as our answer. You try this example. How many protons are there in the nucleus of a calcium atom? Well, hopefully you got 20. How many electrons? Hopefully you got 20. And finally, how many neutrons? Hopefully you got 20. Here are the first two atoms of the first two elements found on the periodic table. So here's hydrogen, which has an atomic number of 1 and atomic mass equal to 1, which means it has 1 proton and no neutrons and 1 electron. Here's a picture of it. So here's our nucleus with 1 proton, and on the outside we have 1 electron in the outermost shell. Helium has an atomic number of 2 and an atomic mass number of 4. So we make a picture of that. Here's our nucleus where we have 2 protons and 2 neutrons, giving us a mass number of 4 and 2 electrons in the outermost shell. Niels Bohr came up with these diagrams to help us visualize these concepts. He was a very famous physicist who came up with this diagram to help visualize atoms or to understand atomic structure. Unfortunately, this is not the way atoms look today. Here's an example of a Bohr diagram, a very generic one. As you can see, in the middle you have your nucleus. On the outside you have shells, and those shells house a certain number of electrons. The first shell houses 2, the second shell houses 8, the third shell houses another 8 electrons. So how to construct a Bohr diagram? First thing you need to do is figure out how many protons, electrons, and neutrons the element contains in one atom of it. Step 2, place the protons and neutrons in the atom's nucleus. Step 3, place the number of electrons in the right shells, filling the innermost shells first and then moving to the outer shells. Remember, the first shell can fit up to 2 electrons, the second and third can fit up to 8 electrons each. Electrons in each shells are represented here. We've only talked about the first 3 shells. So 4 and 5, shells 4 and 5 can hold up to 18. Shells 6 and 7 can hold up to 32 total electrons. Here's a representation of that. K represents the first shell, L second shell, M third, N fourth, so on and so forth. So you can just count the number of dots and that'll tell you the number of electrons. So let's take an example. I want you to be able to figure out the protons, electrons, and neutrons in the element that contains the atomic number equal to 3. So what does that mean? This means that there are 3 protons and 3 electrons in a neutral atom. And a mass number equal to 7, which means that the total protons and neutrons in this one atom of this example of lithium equals 7. So to figure out how many neutrons, we simply just subtract the atomic number from the mass number. 7 minus 3 equals 4 neutrons. When we construct it, we first do the protons and neutrons in the nucleus because that's where they're found. So we put 3 next to the P+, which stands for protons, and 0 stands for neutrons, and we put 4 next to that. And then we place the number of electrons in the right shells, starting with the innermost shells first and then moving outwards. So we have 3 total electrons. We know that the first shell is going to hold 2 electrons, 2 out of those 3, and therefore we have 1 remaining. Okay, so then we fill the outermost shells with the remaining electrons. In this case, you only have 1 in the outermost shell, which is called the valence electron or the valence shell. Outermost means valence in chemistry. So this is the way it should look. You have 2 in the first shell and then 1 as a valence shell, and you're done.